So here we go. We are looking at the second part. We're still in lesson 1, but we're looking at the second part of the lesson. This is tabular integration. Tabular integration, like teletabular, is a shortcut technique to integration by parts. So we're going to revisit one of the ones we saw in the other video, but we're going to do it a different way. So here's the integral. Think of u, think of dv. So this shortcut only works for certain ones. Here is the criteria which must be met in order for it to work. First off, pick a u. Let's say it's x squared. Now if you keep taking this derivative, it must exhaust itself to 0. So the first derivative would be 2x, the second derivative would be 2, the third derivative would exhaust to 0. No matter what this is, even if it were x to the power of 10, it will exhaust itself to 0. If it does not exhaust itself to 0, this technique will not work. Next, you pick a dv which can be integrated every step along the way, and I would say integrated easily. So those are the two criteria. This must exhaust to 0, and this must be integrable. So first we have our u, we have our dv. Now watch what I do. I'm going to go down. I'm going to say 2x, that's the first derivative. Then I'm going to find the next derivative. Boom. And then the next derivative is 0, and that's when I stop. And then I'm going to come over here. I'm going to take the antiderivative, e to the 2x over 2. Antiderivative again, e to the 2x over 4. And the antiderivative again, e to the 2x over 8. I did that until it matched up next to the 0. So here is the important step now. The answer is right here. This times this, this times this, this times this. And that's where I stop. I don't include the 0, but I include this times this diagonal. The other thing is you keep the sign of this product, you change the sign of this product, and you keep the sign of the last product, and then you sum them up. So the answer is, done real easy without a lot of work, x squared times e to the 2x over 2. That's the first one. And then I need a minus, because I have to change the sign. The 2 will cancel out with a 4 to make it a 2 when I multiply. So I have minus x e to the 2x over 2. And then the last one is plus, and the 2 cancels out with the 8 to make a 4. So then I have plus e to the 2x over 4, and then I have my plus c. You see, that was a lot easier. So I'm going to give you one. Promise me that in this next one you actually try it and don't just watch the video. Try it first. So look at that. I scrolled up. So here we go. Here's the next one I want you to try. The integral of x cubed sine x dx. Do your tabular integration, and then let's discuss it together. U dv. X cubed sine x. Derivative 3x squared. The derivative 6x. The derivative 6. The derivative 0. Stop. Now I do the antiderivative. Be careful with these signs. This is going to be negative cosine of x. Its antiderivative is going to be negative sine x. And then the antiderivative of that will be positive cosine x, and the antiderivative of that is positive sine x. We are ready to look at the products. So we multiply cross diagonally like this, okay, up to the last one. Now remember, the plus does not mean it will be positive. It means you keep the sign of the product, change the sign of the product, keep the sign, change the sign. We'll always go in that order. Keep, change, so on and so forth. So we're ready to write the answer, and it's going to be a negative x cubed cosine x, because I'm keeping the negative sign. Then I have a change the negative sign to be plus 3x squared sine x. Next one we will keep a positive, so plus 6x cosine x. And then finally minus 6 sine x plus c. Awesome. You're going to love if I give you one that is tabular ready or tabular approved. So there it is. Hopefully you got that one right, and that's actually the end of the lesson. I hope you watched this. I hope you enjoyed the video. Make sure in class you study hard, do the homework problems collaboratively. I'm there for questions, and so are your peers. So I will see you then.